binomials. And the biggest trick to doing multiplication of binomials is to remember to multiply all parts of one binomial by all parts of the second binomial. And what I use to help me make sure that I've remembered to multiply everything that I'm supposed to multiply is this little multiplication box that I have drawn here. It's just a square divided into 4 sections. And by the time I get done multiplying, each section should be filled with something. And if not, then I know that I am not completely finished multiplying the two binomials. Binomials are expressions in math that have two parts to them. So if you look at my parentheses that I've got up here, each parenthesis has two terms to it. First binomial has x plus 1 as the expression, and one term is x, and the second term is 1. The binomial that I'm multiplying it by also has two terms. The first term is x, the second term is the negative 7, which I can turn to plus negative 7 if I'd like, but I'm just going to leave it as is for now. And then you can look at the sets of binomials that I have for later examples. They also have two terms inside of each set of parentheses. So what is it going to look like when I multiply these two binomials together? Well, what I'm going to do is I'm going to take one binomial and I'm going to write it along the left side of the box. And then the other binomial I'm going to write along the top of the box. It does not matter which binomial you put where, as long as you've got one of each listed along the bottom and the other one listed along the top. So now what I need to do to fill in this box right here, this is the box that's in the first row, first column of my multiplication box. I need to multiply the two items that are around that square. That would be the x to the left of it and the x above it. When I multiply x by x, I get x to the second because I'm multiplying two x's together. Now I need to multiply the number or the item. Most times it's going to be a number, but it doesn't have to be a number every time. I'm going to multiply the number that's on the left side of this box in the bottom left corner by the number or variable that's on the top of the first column. So when I do that, I get 1 times x, which is 1x, and it's positive. So it might not be a bad idea to include the signs. Usually I don't put a plus sign, and if I don't have a sign there, then I know that it's a positive number. Now to move over to the second column, I need to multiply the x, which is on the left side or out in front of the row, by the negative 7, which is on the top of the column. So I get negative 7x. And now to fill in the very last box, I'm going to take the 1 and multiply it by the negative 7, and that gives me negative 7. My last job to do to complete my multiplication is to make sure and combine any like terms that I might have. Like terms, obviously they have to have the same variable, and the variables should not have any, if they're alike, they should have the same powers on them. The terms that I've circled, the 1x and the negative 7x, the x's are both raised to the first power, so that's how we know that those are like terms. And most often when you use this multiplication box to do these, you are going to have the like terms running on that diagonal, just like the diagonal that I've circled. So x squared does not have any like term. I always try to lead my answer with my highest power that's in the problem. Now I can combine those like terms that I have circled, and that's going to give me a negative 6x. And then my negative 7 does not have any like terms. So multiplying x plus 1 by times x minus 7, I'm going to get the polynomial x squared minus 6x minus 7. It can actually be called a trinomial because this has 3 terms now. These parentheses had 2 terms. They were binomials, bi meaning 2. And this answer has 3 terms, and we can call it a trinomial. Tri meaning 3. Okay, moving on to the next multiplication set. I've got 2x minus 3 as one of my binomials, and it's being multiplied by x minus 1. So for the box in the upper left corner, I'm going to do 2x times x, which gives me 2x squared. In the lower left-hand corner, I'm going to do negative 3 times x, which gives me negative 3x. In the upper right corner, I'm going to do 2x times negative 1, and that is going to give me negative 2x. Oops. And in the bottom right-hand corner, I'm going to do negative 3 times negative 1, which is going to give me a positive 3. So now looking for my like terms, they should be on the diagonal. As long as your binomials are always set up the way mine are set up in each and every one of these problems, your like terms should be on that same diagonal. Starting with my highest power first, I have my 2x squared. Now I've got my negative 3x, which can be added to my negative 2x. And if you forget what operation to use, there's a big plus sign right here in the middle staring at you. So take those two terms and add them together. I get a negative 5x. And I got a positive 3 at the end of that. So the trinomial that results when I multiply 2x minus 3 by x minus 1 is 2x squared minus 5x plus 3. Okay, the third example, I've got 3x plus 4 being multiplied by 3x plus 2. I'm going to start in the upper left-hand corner and get 3x times 3x, 9x to the second. In the bottom left-hand corner, I have 3x times 4, which gives me 12x. Well, apparently my software needs to be updated. Sorry for those little pop-ups that keep coming up. Now in the upper right-hand corner, 3x times 2, that's going to give me a 6x. And it's positive, but I don't need to write that. I just know that they're not negative if I don't have any sign there. In the bottom right-hand corner, I'm going to do 4 times 2, which gives me a positive 8. Now when I look for my like terms, again, they are on that same diagonal. And I get 9x to the second. Both of these are positive, so 12 plus 6 gives me 18x, and then a positive 8 at the end. And my last example, I have x minus 5 being multiplied by 3x plus 8. In the upper left-hand corner, x times 3x is going to give me 3x to the second. In the bottom left-hand corner, negative 5 times 3x is going to give me negative 15x. In the upper right-hand corner, x times 8 gives me 8x. And in the bottom left, or the lower left, negative 5 times 8 gives me negative 40. Again, my like terms are on this diagonal. I'm going to start with my highest exponent first, which is the 3x to the second. Negative 15x plus 8x gives me a negative 7x, and then I've got a minus 40 at the end of that. So 3x to the second minus 7x minus 40. That's the lesson for multiplying binomials. If you go online and you look for other videos, some people will teach multiplying these by using the FOIL method. I used to do that, but my students would often forget steps, so that's when I introduced these multiplication boxes. I just want you to know that if you do go online and you look for alternate methods and you see this thing called FOIL, they're doing the same thing that I'm doing. They're just using a different method to make sure that every term in the first binomial gets multiplied by every term in the second binomial. And basically, my box, you're using the distributive property. Okay, the distributive property is what makes this happen. Everything in the first parenthesis is being multiplied by everything in the second parenthesis, and the distributive property is what allows us to do that.